Hello everybody, my name is Marylidia Marroqui and I'm a PhD student from VUB in Belgium. And today I'm going to present you my poster that is called Assessing the Feasibility of Aquifer Storage and Recovery in the Cretaceous Aquifer in Belgium. So let's start from the very beginning. The Natalie project is a European project that promotes resilience to climate change with nature-based solutions in different bioclimates in Europe. So we have 18 different nature-based solutions for climate change. In this moment, we are going to focus in the case study number 5. That is the one where I am involved with other 4 partners. This case study is focused on storing water underground. Why? Because there we have a big buffer when we can just store the water for a period of time and then recover it when we need it. So we want to check if it's possible to do it in the Cretaceous Aquifer. And what we want to do is to inject the water in certain point, let the water flow for a period of time, and then recover it whenever we need it. We want to check what is the storage capacity of the aquifer, how long it will travel, how fast it will do it, and which changes are going to happen with the hydrochemistry. So this is our conceptual model, but also we have to do it in a more numerical way. The first part of the project is checking where is it possible to put the wells. So we did it in ModFlow with a 3D groundwater flow model. We started with a regional model, and then the output from the regional model we used it to build a more local model. And with that we run a series of different scenarios to check which one was the best position for each of the wells. So these ones are the results of the different scenarios where we noticed that we were going to recover the water if we extracted from 3 different points, but we also noticed that we were going to take a long period of time to recover this water. So for the time framework that we have, there is a certain amount of years we want to let the water travel not for too long for our pilot site, because we are going to do it physically. It's going to be an experiment. So we wanted to reduce this period of time and be able to measure for longer time and see which ones were the reactions and everything in the aquifer. So we reduce it, we put our wells a bit closer from each other. We also try to increase a bit the injection rate to check if that had a different response. And we noticed that we were going to take, if we were separated from around 50 meters, around 1 month to 3 months, and if we were separated around 125 meters, we were going to take between 3 months, more or less. So at the end, we went to the field. We checked where it was possible for different reasons. When you have a place where it's very crowded, you have to really check where you are going to put your things, because cables and everything can be in the way. So we decided to put it in this point, and then we're going to extract 62 meters farther. And we're going to also have a monitoring well where we're going to check if what we model is the same as the conditions that we have in reality in our place. So now the next step is going to be installing the wells, getting the permits, put them in the field, and next doing a pumping test. And with the result from the monitoring and everything, we're going to implement them in the model and try to do it as realistic as possible. So thank you so much.